On this next question, we're going to talk a lot about even and odd functions. Let me just read what's on the screen real quick. It says, we can classify functions by the type of symmetry they have. Functions can be even, odd, or neither. An even function is symmetrical about the y-axis, which means it can reflect the graph over the y-axis and get the same image. Algebraically, we can check whether the function is even by substituting a negative x for a positive x in the function and determining whether f of negative x is the same of f of x. So in other words, if I plug in a 2, whatever y value I get, I should get that same y value if I plug in a negative 2 for x. So an odd function, though, has symmetry, about the origin. And so, which is a rotational symmetry about the origin. In other words, we can reflect the graph over the y and then over the x-axis and get the same image. Algebraically, though, what it means is when I plug in the negative x, I get the negative y value. So let's zoom in on the graph and we'll talk about that, and then we're going to have a question that relates to it. So I have some even functions here. And so basically, graphically, as you can see here, they reflect about the y-axis. So the y-axis is like an axis of symmetry, right? The left-hand side looks exactly like the right-hand side graphically. So these are even functions for sure because the y-axis goes right through the middle of the image. It's symmetrical. Now, what they're talking about algebraically is whatever this value is right here, that's a negative value. Well, let me back up and we'll find when x equals -1, I've got this value here. When x equals +1, I have the same corresponding y value. So f of negative x is equal to f of positive x, right? So I've got a -1 here and a +1 here, but I still have the same y value, okay? And the same thing goes for here, right here at -2, right here at +2. So algebraically, we say -2, comma 0, and then +2, comma 0. And no matter what x value, right here at 3 and -3, this is -3, comma 1, and then this is 3, comma 1. So they have the same y value, even though my x's are opposite. Now, for an odd function, if I go to 4, comma 4, right? So my x value is 4, comma 4. When I change that x value to -4, then I have the opposite y value as well. That occurs on the odd functions. Okay. Over here, I'm not quite sure what this value is, but it's like x -1, comma 2, we'll just say 2.2. Well, over here, I'm going to have the opposite of that. When I change that to +1, I get -2.2. So when you have the opposite x values, it also changes the sign of the y values, okay? And they become opposites. So now the question asks us to consider this function tangent. Tangent of 3x plus pi over 4 minus 1. So we can determine if it's even or odd by looking at the negative values and the positive values. Well, first of all, it's It's not reflected. So let's look at it graphically. If I draw a line down the y-axis, does the left side look like the right side 100%? No, it's not symmetrical about the x-axis. Or I mean the y-axis. It's just not. Okay? So it's not even. And then, is it symmetrical about the origin, graphically speaking? See how this one looks? This one looks like if I cut this and rotate it 180 degrees, I get this. Same thing here. If I cut from here to here, if I take this thing and I rotate it 180 degrees, that's what I would get. Graphically, I can't do that with this. So it's not odd. So then we would say, which statement best describes this? The function is neither even or odd. So that's how we answer that one.